that's the right thing. And nesting has to do with it's 3 points. Basically, the conditional statement is in the loop, which means you cannot get out of the loop because the conditional statement, the condition of the conditional statement, is false. You have to get out from the loop itself. Exiting from the conditional statement still needs to continue with the loop. Basically, that particular point. So when you get to Moodle, you can see the score for question number 1, and then we'll do exactly the same thing with questions 2, 3, and 4. So are there any questions about how to check your grade, for this exam? And there will be, all the questions will be broken down kind of like this. I try, to break it down to the point where I can qualitatively say, okay, okay, these points, check, these points, check, and so on. But there are still kind of cases where I have to do a judgment call and just say, okay, it's not exactly, listed, as a category, because it's really hard for me to anticipate how people can, get it incorrectly. Okay, so sometimes, the grading scheme still needs to be changed, especially for question number 2. Question number 2 is going to take me at least, an hour or 2 just to grade that one question because it's so open-ended. Okay. Are there any questions about number 1, the grading standard of number 1? If there are no questions, we'll go over the question itself, so we can actually see what it is and what I'm expecting, from the answer. I don't think anyone or too many people are interested in question number 1 because it's a fairly easy question to answer. There are 4 versions of question number 1. I'll just pick one of the versions. It doesn't matter which one I pick. And it's using the wrong application to open. I want Zerno is interesting, but I don't want to use it. Okay, so this is question number 1, and let me just zoom into the question itself. This is the loop, and also with a conditional statement inside the loop itself. Do you guys want me to actually do it and show you the trace, or is that okay with this one?
It's okay.
Look, I'll just go ahead and trace it anyway. Just trace it once. It's quick enough to do it. So depending on which version of the question you get, these numbers can be a little bit different. So the behavior of the loop is also a little bit different. But basically, they're all about the same, with a loop containing a conditional statement, one statement to change x, one statement to change y, and you have. But the condition of these 2 are pretty much the same. So let me go ahead and just trace this one. Oh. X gets a value of 2, y gets a value of 5, while x is less than y do. X gets x plus 1. So here's question number 1, and I'm going to trace it next to it. Comments, line number, and then the 2 variables. The precondition is we don't know anything about x or y because we initialize both variables right away. Line 1 initializes x, line 2 initializes y. So there are no points allocated to the tracing of the first 2 lines because there's nothing significant about those 2 lines. Line 3 is evaluating the condition, whether x is less than y. In this case, x is 2, y is 5, so x is less than y is true. When the condition of a while loop is true, we go into the body of the loop and we execute line 4 in this case. Line 4 is adding 1 to x and put the result back into x, so x goes from 2 to 3. On line 5, we have to evaluate the condition again. X is less than y. It is still true because x has a value of 3, y has a value of 5. So the condition is still true. When the condition of a conditional statement is true, we execute the then branch. In this case, it is line 6. Line 6 is subtracting 1 from y. Y goes from 5 to 4. And then we get out of the conditional statement. So at this point, we have to go back to the beginning because out of the conditional statement, this is the last statement inside the loop. But as a last statement inside the loop, after we are done with this, we have to go back to the beginning of the entire loop, which starts with line 3 again. Are there any questions about this at this point?
If you went to line 7, is that incorrect?
If you go to line 7, I would not mark it as incorrect. Question?
That's what I would say, to have the post 7.
I saw that, okay, I saw you indicate post 7 and post 8, I do not deduct points, it's not needed, okay, we don't track line 7 or line 8, but I don't take points off from it either. So we go back to line 3 and then we re-evaluate x is less than y. It is still true because x has a value of 3 at this point, y has a value of 4. So the condition is still true, we go to line 4 again. On line 4, x gets x plus 1, so x goes from 3 to 4. Then we go to line 5 again. This time x is less than y becomes false because both x and y have the same value of 4, so that's why x is less than y is false. Okay? Most people do not have any problem spotting, oh, okay, the condition is false. The question is, what are we supposed to do next?
Line 3.
We have to go back to line 3. Now, some people put a post right here. Those people will get the majority of the points, but I still take 2 points off because even for the last iteration, the program still has to go back to line 3 and then it gets out of the loop. Okay? So I did not take a whole lot of points off, because at this point, most people have shown me that they know that in the loop you're supposed to go back to the beginning, except in the last iteration, you still have to go back to the beginning to check for the condition and then get out of the loop. So the correct answer is we have to go back to line 3. Line 3, which is the loop condition, will be evaluated to be false again. Then we get out of the program. Okay, I take 2 points out of 15 points. I think that's a fairly minor deduction, considering in this class 37.5% is a C. Right? So any questions about this one?
37.5% is a C.
Yeah, it's in the syllabus.
Oh, wow.
It's in the syllabus.
Makes me feel a little better.
I don't think most people would have a problem with this class, passing as long as they do the homework and actually, do all the work. Just making a folder of this class for today so I can save the file. Shall we move on to the next one? This next one, for question number 2, I'll just pick one of these random versions. Okay, this is the one that I picked. And we'll zoom in. Okay, this is the one that I really do not look forward to grading, but I have to do it. Because just from glancing over the answers, I can see let's just say there's a variety of answers. Okay. Which usually makes it kind of difficult for me to grade. Oh, is that question number 2? No, that's question number 3. Okay, I picked the wrong one. Okay, let me take question number 2. There are only 2 versions of question number 2. I'll pick B. Okay. Okay, so here's question number 2, and for this one, I have to use a text editor to give you the answer. I will save that to anyway, to today's folder. Okay, there we go. Okay. So first of all, let's read the question carefully. Okay, the question says, we have, the following piece of code. Just for reading, I have to zoom out again. Come on, wake up. Refresh. It's being sleepy. Yep, it's being very sleepy. Let me just close the window that I don't need.
Oh, you got a Linux virus.
Nope, it's not a virus. Okay, let me just close this. And open again. Okay, so here we go. Okay, are there any questions about question number 2? No? Okay. Let's go ahead and go ahead.
The whole thing in general.
Yeah.
Yeah. Okay, the whole thing in general. Okay, well, first let's read the question first, and then we'll talk about how to deal with it. Okay, the fragment of code is like this. Okay, line 15 to line 20 is a part of a program, so it's not really at the beginning of the program, nor probably not at the end either. But we don't care. It is just somewhere in the middle of a program. So we can confirm by observation in the post condition of line 20 that x equals 5. Okay, that's what we can observe. In other words, let's say the program is not doing what it's supposed to, and it ended on line 20, and at that point x equals to 5. The question is asking, oh, there's more. Okay, x equals 5, and y equals 4, and k equals 4. So those are the conditions. We can confirm that because when I stop the program's execution, I can observe those variables have those particular values. So there are 2 things to do. The first thing we want to do is to figure out what is pre-15. In other words, if I tell you the post condition of line 20, can I go back and say, oh, if I go back to line 15, this will be the precondition before line 15 executes? That's the first question. I did not ask anyone to show the steps for the first one because the second one will verify it. So the second part, then using pre-15 and pre and post condition derivations, not tracing, okay, that's a key word here, prove that your pre-15 will result in the confirmed post-20. Does everybody understand the nature of the question? You have to use reasoning to go back to line 15, give me a precondition of line 15. Then you have to go forward again using the forward derivation to tell me, to prove that your pre-15 is in fact correct. Okay? So let's go ahead and deal with this question, and I will work on it using my text editor. Question? No? Okay. First of all, question? Oh, okay. So what we know is post 20 is x equals what? 5. And y equals 4. And k equals 4. Okay. Can I figure out what is pre-20?
Yes.
Okay, if you look at line 20, what does line 20 do to k?
Add 1.
It makes it 1 larger than before. Okay, that's all it's going to do to that. Okay, let me make sure that I'm still recording from the right channel. I may not be recording from the right channel. No, it is. The program is smarter than I am. Okay, so what do we know about x before line 20?
5.
Because line 20 does not change x, right? What about y? Same. What about k? K would equal to 3 because after adding 1 to k, it became 4. So before I add 1 to k, it should have a value of 3. Is that working out so far? Okay. Now, if that is the case, if I know what is pre-20, can I say something about post-19?
It's the same as
It should be the same, right? Because line 19 is the end of the conditional statement, and line 20 is an assignment statement. So line 20 follows line 19. Okay, those two lines are sequential. So that's why I can, make a conclusion and say post 19 is the same as pre 20, and I'll just go ahead and copy and paste whatever I have here. Is that making any sense so far?
Okay, so in this case, because we're explaining it, we needed to...
You don't have to do this, okay? You don't have to explain it. However, if you don't go through this process to explain it, you might miss one of the cases, okay? Because when we get back to pre-15, it is actually a disjunction. There are two combinations of conjunctions that can lead to the same result, okay? So post 19 is this. What is post 18?
Same thing.
Post 18 would be the same thing, so it's the same thing as post 19, and we'll just go ahead and copy and paste this part here. And the same applies to post 16, right? Post 16 is going to be the same as post 19, which is also going to be the same thing. Is that making any sense so far? I'm just, going upstream, because there are no statements between line 16 and line 19. There are no statements between line 16 and line 18. Is that? Whoops, I take it back. There are no statements between line 18 and line 19. There are no statements between line 16 and line 19. And therefore, whatever is true on line 19 will still be true after line 16 or line 18 has executed. Is that okay so far? Okay. Now, if that is okay, if I know that post 18 is this condition here, what can I say about pre-18? If you look at line 18, what does it do? It adds x and k together and change x accordingly using that result. So what can I say about pre-18?
X is equal to 2.
X equals to 2 because k is 3. Okay? And y equals 4 because it does not change y. And k equals 3 because it does not change k. Is that okay so far? I'm just going one step at a time. What about pre-16? What does line 16 do? Line 16 is easy. It's just subtracting 1 from x. Okay, so after taking 1 away from x, x ended up with a value of 5. So what would be the value of x before that happens?
6.
X equals 6, and y equals 4, and k equals 3. Now that's not really quite the end of it, because if I get to line 18, what else has to be true?
15 is false.
The condition of line 15 has to be false because we are just about to execute the else case. So we have to say, x is less than y. Is x less than y? It is. Okay, so the whole thing is consistent. Now, if the whole thing is consistent, you can just remove this part here because it does not add any new information to the conjunction. You can leave it in, you can take it out, either way it's fine. How about line 16? Does it make sense? Because if I get to line 16, x has to be greater than or equal to y. Is x greater than or equal to y?
Yes.
You're good? So we can put it in here. It doesn't have to be here, but if you want to, make sure that we don't have a dead branch situation, you have to keep track of the conditions like this also. So now we combine the two branches back to pre-15. Okay? What do you think is pre-15?
X is equal to 6 or x is equal to 2.
Okay. Well, it becomes pre-16 or pre-18, right? Because we have two ways to merge those two paths back into line 15. So it is a disjunction of the two big, messy conjunctions. So if you want to just give it the final form is going to be, this is pre-16, So we just copy and paste this part here. And then the second part is pre-18, which is this big mess here. Okay. Well, there is a way to simplify this. Okay. If anyone is interested in simplifying this, I can do that too. Can anyone identify the really common parts of the two conditions?
Y equals 4.
Yep, so we can take that out. It's just like with multiplication and addition, you can also apply the law of distributive, you can also apply the distributive law with Boolean expressions. So in this case, you can simplify the whole thing. The first thing is I will take this out, okay? Because if I know that x is 6 and y is 4, it is automatically known that x is greater than or equal to y. So the highlighted condition does not add anything new. And the same thing applies to here. It does not add anything to new, so we can take that out. In other words, after the simplification, we have y equals 4 and k equals 3, and the whole thing, basically x equal 2 or x equals 6. That would be the final result. Okay, so that's the first part. That's the first part. The second part is to take this and then you go through all the forward derivations to get to the answer.
We
Okay.
should have went over this one, but I don't get it.
You don't get it? Well, are you okay at this point? Do we understand how we get to the pre-15 being this big mess here? Because it's all step by step. The reasoning here is step by step. You do not need to give me step by step reasoning, okay? And I see that a lot of people did not, give me step by step reasoning to go back to pre-15. If you don't give me step by step reasoning, most people, I would not say everybody, most people will only get one or the other and not remember that there are two ways to get to line 15. Okay? So shall we move forward, from here? Just, kind of prove that this is the correct precondition? No one cares? Okay. Okay, so let's go ahead and move forward, okay? If I want to move forward and use pre-15 to figure out what is pre-16, what is pre-16? Pre-16 is pre-15 because there are no statements between pre-15 and line 16 and the condition of the conditional statement. Is that right? Okay. And I can do the same thing with line 18. Whatever is true before line 15 has to be true at this point, but at the same time the condition has to be false because otherwise we would not be about to execute line 18. Okay. So in this case I can expand what is pre-15. So pre-15 is a big huge mess like this. And I have to say, oh, by the way, x is also greater than or equal to y. Now I have to do something. Because if you look at this big expression here, inside this parentheses we have a disjunction, which means x can be 2 or x can be 6. If x is 2, this is not going to be true. So that means if I know that x has to be greater than or equal to y, I have to eliminate x equals 2 inside the disjunction. Okay? So this whole thing will simplify to x equals 4 and k equals 3 and x equals 6. Because x equals 6 is the only case inside the disjunction that can also satisfy x is greater than or equal to y. But because we know the exact value of x and the exact value of y, this comparison is also no longer needed, so I can simplify that out as well. Are we okay so far? Okay. What about post 16? How do we get to post 16?
Subtract 1 from x.
We have to subtract 1 from x, but since we are going to use the pre and post conditions, we have to go through that whole motion of figuring out whether the right-hand side refers to the left-hand side and all that stuff. So in this case, on line 16, the right-hand side refers to the left-hand side, and it is reversible. If I define f of x to be x minus 1, then f prime of x, which is the inverse function, is going to be x plus 1. So then you can say apply the substitution rule, which means post 16 is sub 316. We take the variable on the left-hand side, which is x, and replace it with f prime applied to that variable. So we end up with what? We end up with 316 is somewhat of a mess, and f prime of x is just x plus 1. Fortunately, out of the entire mess, most of it does not refer to x. So I can copy and paste most of the stuff here. This is the only part that refers to x, and we have to replace x with x plus 1 equals to 6. And if you do one simplification, then you get x equals 5. Is that okay so far? Now this part has nothing to do with, the reverse, the tracking back, the reverse thing. You can go forward, anytime you have a precondition of a conditional statement, you should be able to go forward and just apply all these rules. Let's check, what is pre-18. Okay, pre-18 is this mess here, and then we have to copy pre-15, which is this part, and then we have to say, oh, by the way, this time we have to make sure that x is in fact less than y. So if you look at this whole thing, x can be 2 or x can be 6. When x is 6, x cannot be less than y because we know for sure that y equals 4. So that means we have to eliminate this case out of the disjunction and only have x equals 2 remaining inside the condition. So that's why this whole thing simplifies to y equals 4, k equals 3, and x equals 2, because x equals 6, it has to be eliminated, and then x is less than y. But we can also simplify x is less than y out, because knowing the exact value of x and y, we don't need to say that x is less than y. If you leave it in, it's not a problem. Okay, it's just that I would simplify it as much as I can, so later on I won't have as much stuff to deal with. What about post 18? Same thing. I would since I can't do it here, I would just copy and paste some of the stuff I have for line 16. On line 18, it's the same thing. The right-hand side refers to the left-hand side. X equals x plus k. That x on the right-hand side is still referring to the same x on the left-hand side. So it's still applying this rule. And in this case, I will call this function g. The original form is x plus k. So that means when we figure out the inverse function, it is x minus k. When they apply the substitution rule, it becomes something like this. G prime in this case. And then we take pre-18, which is this condition here, put it down here, x, and then g prime of x is x minus k. We do the actual substitution. Fortunately, most of these components do not have x. Only the last one has x. X minus k equals 2. And since we know what k is, we can also figure out what x should be after this operation. Okay. Any questions at this point? No questions? Okay. And then we can go forward again. We go to post 19. Post 19 is a disjunction of post 16 and post 18 because we can get to the end from the end of line 16 or from the end of line 18. So post 19 is post 16 or post 18. And we'll just go ahead and copy and paste a lot of stuff here. And you will see one particular interesting pattern. What is the pattern here? They are exactly the same, and they should be. Okay? So if you have two conjunctions or two things, if you have two conditions joined by a disjunction and they're exactly the same thing, can we simplify it? You just pick one side, because they are identical. So that means this whole thing is simplified to just this. And then we're almost done because we still have line 20 to deal with. And we can just copy the same type of reasoning for line 20. On line 20, the right-hand side refers to the left-hand side, and it is reversible. And this time I have to use function h to apply to k. And the original function is k plus 1. The inverse function, h prime, applied to k, is going to be k minus 1. The rest is really just mechanical. Okay, we just say post 20 is substitution of pre-20. We take all occurrences of k and replace each one with h prime applied to k. Pre-20 is the same as post-19 because those two lines are sequential, and that's why we can copy this portion to be our pre-20. H prime is k minus 1. And when you do the substitution, I'll just go ahead and copy the whole thing down and just replace the k with k minus 1. If you know k minus 1 is 3, we know k equals 4. And that's the answer. Are there any questions about this? I mean, yep.
Do you have the scoring model for that question?
Not yet. I figure that's going to be a difficult thing to do, so I'm procrastinating. I basically have to look for the reasoning. Okay, some points will be allocated to what people tell me about pre-15. So this part will definitely worth some point. And I'm anticipating that some people will miss portions of that. Then I have to figure out what each portion is going to cost, because it is important to get back to the disjunction. This is the important part. And then going forward is fairly mechanical. Okay, you're just applying all the rules that we have learned in the class. In fact, you can get pre-15 wrong altogether and still be able to derive everything to the post condition. Except the post 20 is not going to be the post 20 that I give you. It'll be a much more general form of post 20. So a lot of points will be allocated to stuff like this. Pre-16 is the precondition of the conditional statement and the condition itself. So that stuff will worth a lot of points, which I think is helpful. If I put a lot of points into pre-15, I think that will hurt more people. So that's why I have not decided yet on the point allocation. But once it is decided, it will be applicable to the entire class. So I'm not going to take a look at one person's answer and say, oh, for you, I'm going to put more weight on pre-15, and then take a look at the next person and say, oh, for you, I'm going to put more emphasis on put more points into the derivation itself. So in other words, it will be just like in question number 1. I will publish the point breakdown and use exactly the same grading scheme for the entire class. It's just that it will take me a little bit of time to figure out what is the best way to break down the points. As far as the answer is concerned, is that okay? Okay, the reasoning is okay. It's a little bit long. And some people ran out of space, and have to attach a separate sheet of paper on this one. Okay, so that's question number 2. Let's move on to question number 3. There are 4 versions of question number 3, but question number 3 is the easy one. So I don't think we have too much of a problem here. This is one version of question number 3. They're all about the same. They're not really that different. And question number 3 is a trace. It is not a loop. It is just a conditional statement. So for the most part, it's a what? 1, 2, 3. It's a 3-line trace and 4 lines, including the post. Okay, and it's worth what? 5 points. That's why it's only worth 5 points, because it's a fairly easy one to track down. Do we want to go over this, or is that okay and we don't need to go over this one? I'll just verbally go over it, just so that you guys know, what I'm expecting. Okay, we're starting on line 14 because, there's no pre, because we have line 15 here. So at the end of line 14, we know x equals 100, y equals 2, and k equals 25. In this case, is x less than y? You compare 100 to 2?
No.
That's not true. So on line 15 here, you have to say the condition x is less than y is false. If x is less than y is false, where do we go?
18.
We go to line 18. So line 18 will be on this row here. Line 18 will only do one thing. It's going to subtract 1 from y, from x. So x will go from 100 to 99 in this cell here. Then we get out of the conditional statement. We go to line 20 over here. Line 20 is going to add 1 to k. So k will go from 25 to 26. And post. That's it. Okay, so I think that should be an easy 5 points for most people. Yep.
Line 18, you said one taking out of 100 or 102?
It will subtract 1 from 100. Since x is 100 already, it will become 99. 100 minus 1 is 99.
I thought x is 102.
You may have a different version because there are 4 versions.
Oh, okay.
So you have to compare your pseudocode to the pseudocode that I have here. But when I grade it, I would look at which version of the question you get, and then I'll grade yours according to the question that you get. Okay. Any other questions about number 3? Number 3 should not be a big issue. Okay. So let's move on to question number 4. Question number 4 also has 4 versions. Let's pick version D. Okay, question number 4 looks kind of messy. It looks like a kind of difficult question, but you just have to reason it out, okay, to find out when we can get to a particular branch, so that z can end up with a particular value. So what I'll do is I'll use the text editor again, and put it kind of side by side. Then we'll figure out what can happen in each case. Okay, so we look at line 5. Okay, in this case, you don't have to give me the reasoning. You just have to give me an example of how I can make z equal to 0 after this code. How can I make z equal to 1 after this code, and so on. Okay, so in the case of z equals to 0, what kind of condition do I need to get to line 5? Okay, we need x greater than y to be true. We need x mod 3 equal to 0 being true. And we also need y is greater than 20 to be true. Can I find a case like that? Can I find a case where y is greater than 20, x is greater than y, and x is divisible by 3?
Yes.
20 and 21? Okay, y being, not quite,
Yeah.
27.
y equals 21 and x equals 24. Okay, that will work. So in this case, we can have one test case is x equals 24, y equals 23, whatever, doesn't matter. Okay. Okay, the next one is line 7. On line 7, z will become 1 after that assignment statement. But to get there, I need x to be greater than y, I need x mod 3 to be 0, and I need y to be less than or equal to 20. Is that part okay? Does everybody understand why I have to change the last part here? Because it is the else part of this guy. Okay. And how can I make that happen?
X equals 24, y equals 19.
Yep. There are many combinations that will work. Yep. So I'm not looking for a unique answer. For this one, the way I'm going to grade it is I would have a little calculator, a script of sorts, and I'll just punch in your numbers, and the script will tell me whether it works or not. I'm just lazy because if I do it by hand, I'm going to miss something. But if I use a script to do it, it won't miss anything. Okay, on line 13, how do I get to line 13? To get to line 13, the first condition has to be false, right? So x has to be less than or equal to y. They can be the same. What else has to be true? X mod 2 has to be 0. And y also has to be greater than 2. Okay. So let's see here. So the biggest constraint is x mod 2 equals to 0. X has to be even. And x has to be less than or equal to y. How about both of those being 4? Would that work?
Yeah.
If x is 4, y is 4, x is less than or equal to y, because they are equal, they do equal, x mod 2 will be 0, because the remainder of 4 divided by 2 is 0, and y is 4, 4 is greater than 2, everything works out. What about z equals 4? Well, it will be about the same as the previous one, so I can copy and paste most of it, except y has to be less than or equal to 2. Well, can I find a case like that?
Where x equals 2 and y equals 2.
How about that? They can be zeros. X can be 0, y can be 0, because if x is 0 and y is 0, x is less than or equal to y is true. 0 mod 2 is 0. 0 divided by 2 has a remainder of 0. Okay? You can pick negative 2 if you want to. That will work as well. Y is less than or equal to 2. That still works. You can also make x equals 2 and y equals 2. That works as well. Because y will still be less than or equal to 2 when y equals 2, and the rest of the conditions will also kind of fall in place as well. So that means there are tons of possible answers. You just have to give me one case for each possible value of z. But there's one more. What about z equals 5?
You don't really have to do it. It's automatic.
No, it's not automatic. Because remember, z gets 5 is executed first. And then you have the conditional statement. So that means with these cases, okay, z will get 5 initially, but because of the conditional statement, z will eventually get overwritten by 0, 1, 3, and 4. What about z equals 5? That means I cannot get into this part, this part, this part, or this part. That's actually pretty easy to figure out. Okay, if you want z equals 5, you can make x greater than y, so you can get into this condition here, but you want to make x mod 3 not equal to 0. That will make it happen, right? And x mod 3 does not equal to 0. That will make it happen. Can someone give me a case where x is greater than y and x mod 3 is not 0?
X equals 5. 5 for x.
5 for x. Okay. And y just has to be less than it. I mean, there's no other constraint. So y can be 0, y can be 4, doesn't matter. You can also go the other route. You can also say that, I can make it happen when x is less than or equal to y, which will force me to go to line 11. I just have to make the condition of line 11 false. Well, that's not too hard to do. X mod 2 has to be non-zero. So x equals 5 will work too. And in this case, y can be 5 as well, because I just need x and y to be either the same or x has to be less than y.
What about Z2?
Yeah, you have Z2.
Z equals 2 is not possible because none of these assignment statements will do it.
Then what you have?
But you guys can spot it and say, oh, that's not possible. It's not one of the possible cases.
So we can just put C cannot be 2.
Yeah. Yep, exactly. You have to write something, cannot just leave it blank. You can just say that there are no assignments to make that true, right?
Yeah, you get a 37, you get a C.
That's almost like a post-checking, mechanism. So, are there any questions about the exam? I think we finished, all 4 questions. Yep.
So the mod refers to the remainder of y or the x?
It's the remainder of the division.
So is the x over y or y over x?
In this case, it will be x divided by 3. So it is the remainder of x divided by 3. Yeah. We talked about that when we do the factoring thing. Any other questions about the first exam? No other questions? Let me make sure I save that. We have 20 minutes left to start on a new topic because we are almost done with arrays. So we can start to talk about searching in an array. How do you look for a particular value in an array? This is also a good time to pass the row sheet. I really do not need to pass the row sheet today because I can see who did not get an exam back. But, it's probably a good idea to do it anyway. Sorry, we can always do restart. How is the first test? Is it difficult, easy?
Question number 2 was harder than I expected.
Yeah.
Question number 2 is, is it hard in terms of not knowing what I'm asking, or is it hard knowing what I'm asking, but it's hard to get to the answer?
Basically, like, if you
I
gave
thought I
us
had
the
it right.
pre-15, I could have done it.
Okay.
If we had the pre-15 already.
Uh-huh.
But we needed to find pre-15 first,
Mm-hmm.
then execute it.
Right.
That's the part where...
You have to work backwards,
Yeah, I
step
think
by
that's
step.
where I messed up.
Oh, other people agree?
Yeah, you would think you should.
Writing it all out.
Hmm?
It's just writing it all out.
Is writing it all out, or some people can track it in the head, or better yet, you can also use, because you guys are lucky to have a paper version of this test. So what you can do is you can use a pencil or pen and just insert the condition right between 2 lines, because that will give you a pretty visual way of saying, oh, okay, between here and here, that has to be the condition. And my browser does not like to work today. I don't know why. It's okay, I can try a different browser. Getting stuck as well. Do we have another browser? I think that's it.
We had a problem on Thursday in political science. It wouldn't work either.
I don't think this is a networking issue. I think it's it has to do with my flash card. Yeah, it looks that way. That's all right. I can still teach the class. No need to panic yet. Okay, let's talk about searching. Okay, how to find an item in an array. That's what we're trying to do. Okay. So what we want to do is to kind of imagine that we have an array. Okay. Well, I can use the notepad to do it. Notepad still works. Okay. So in this case, let's just say that the array is not sorted. If an array is not sorted, are there any really tricky ways to go through it to find an item? Not really, right? If I tell you your phone book is not sorted in any particular way, and you have to find a specific name, how do you go about doing it?
One by one.
One by one, sequentially, right? Now, some people do it sequentially, one by one, knowing that there's no way around it. Other people may try their luck and just kind of flip to random pages and see if they get lucky, okay? What is the problem of going to random pages and see if I'm lucky and just, oh, I hit that name, just by random? You can't remember which page you have flipped to previously. That's the problem. So that's why it is always a better idea to go sequentially. Go from the beginning and just look at each and every single item and see which one is matching the item that you're looking for. For this one, I'm not going to use an example first, so we'll get started with the algorithm itself. Do you think this is a repetitive process? Just imagine that you have a phone book that is not sorted and you have to find a particular name. Do you think this process has some kind of loop or some kind of repetition in it?
Could be.
I think it's repetitive, okay? Because you have to keep flipping pages, right? You have to keep scanning. You have to look at one item. Oh, that's not it. Look at the next item. That's not it. Look at the next item. That's not it. So that's repetitive because you are looking through the items sequentially, and you're doing it in a loop. So we'll say that we have a loop here, and every time we have a loop, we have to think about when do we get out of the loop. Just imagine that you have a phone book in front of you, and this is a San Francisco Bay Area phone book, so it's really thick, okay? And you have to find a particular name. When can you stop?
When you found the particular.
When you find the name,
Or you hit the end of the book.
or you hit the end of the phone book, or you pass out in the process. Okay, okay, well, we'll just go ahead and say that, okay? Exit the loop when the item is found. Okay, that's one condition. And then the other condition is there are no more items to examine. Okay. What should I use here? Should I use an or? Should I use an and? Or what?
Or.
We should use an or because both of these are conditions to get out of the loop. They're both reasons to get out of the loop. Okay, we put an or here, and it just automatically wrapped around. So there we go. This is my first revision. I'm not ambitious. I just want to capture a little bit of the logic and not even figure out how to express it in a very concise way. In revision 2, I look at this and go, well, that's awfully vague, okay? This item, more items, and so on and so forth. Let's start to use terminologies related to arrays. So let's say we are not dealing with a phone book anymore. We're dealing with an array of items. I don't care what are the items. They can be names, they can be numbers, they can be social security numbers, and whatnot. I don't care. As long as I can compare to see if two items are the same, I'm good, okay? So in revision 2, I introduce programming concepts and use variables and arrays. So in revision 2, we say let array A store the items to be searched. And I also need another variable because I need K be the value that we are looking for. Okay. Is that okay so far? And then we'll say let I be an integer to keep track of which item we are examining. Okay. So with these three variables defined, can I refine my loop? Can I refine the conditions of my loop?
Yeah.
Okay. How can I refine it when the item is found versus there are no more items to examine? How do I say this when the item is found? Now, where am I searching again? What is the construct that stores the item to be searched? It's in the array A, right? Can I do something like this? I mean, it looks like I can do that. Does it make any sense?
No, that's the entire array.
That's the entire array. In other words, okay, let's say you have an array of coffee mugs, again, a box of coffee mugs. And each coffee mug, inside the coffee mug can have a different level of liquid, right? And I'm asking, hey, look at box A here. Is it half empty? That's my question. But my real question is there a coffee mug in the box that is half empty? This, on the other hand, is asking, is the box itself half empty? Which does not make any sense, because the box has multiple mugs, and each mug can have a different level. So I cannot compare an array to a particular value just like that. I have to say which item or which coffee mug in the box am I comparing. So in this case, I'm just saying that there's one variable I to control which item in the array I'm looking at. I don't even care how I maintain the value of I. I just know that I can use a value of I as an index to go to one particular item and say, okay, do you have the value of K? And that's all I care, because if I can find one item in the array that has the value K, I can get out, because all I'm looking for is one item that has that value. Okay. The second one, we'll deal with it later. Okay, so we'll call this revision 2. Okay. So in revision 3, I have to do something else, because I cannot express the last part of the logic. There are no more items to examine. How do I know there are no more items to examine? It goes back to the approach like in the phone book. If you just kind of flip to a random page, search on a random item, oh, that's not it, I guess I'm just not very lucky. Flip to another page randomly, and then look, and then use the same approach. There's no way you can remember which page and which item you have already examined, and that's why it's not a very good idea, because there's no way you can tell there are no more items to examine. So how can we do this more systematically so that we can say, oh, we know for sure those items we have already examined, and we only have those items on the other side that we have to examine.
So if we start at the beginning and we go to the end, we can show we've done everything, and we know that I is going to keep track of how many items we've done. So
Have already examined, right?
We've already examined, yeah. And so A bar should be the total number of items. So if I is equal to A bar,
A bar.
we should be done.
Okay, so we have to determine the direction to search in array A. Okay, now there are no specific reason why we have to go from front to back. We could have gone from back to front, okay, as long as it is in one single direction and it's easy to keep track of what has been searched already and what is yet to be searched, it is okay. But from the perspective of computer architecture, to make your program go faster, there is a reason to go forward instead of backwards. Can anyone, well, this is not the right class to really expect an answer, but I just want to see if anyone has any rough idea why I say that. Why it is actually advantageous in this case to go from the front, going from A bracket 0 to A bracket bar A bar minus 1, instead of going from the back to the front. Why would it make any difference? It doesn't have to do with adding 1 is faster than subtracting 1. They take exactly the same amount of time. Yep.
You don't know how many numbers in the book?
But in either case, you have to know the number, the number of items.
You just go forward. You just go up. You don't have to know how many numbers.
You still have to know. In fact, you can argue that the other way around is faster, because if you start from the back to go to the beginning, then you are only comparing I to 0, because when I hit 0, you know you're looking at the first item. But when you go in the other direction, you have to compare to the size or the number of items in A, which may or may not be easy or quick to compute. The reason why this is better, going from front to back is better, is how many people know what is DDR2, DDR3, and all that stuff? Okay, what is DDR2 and DDR3? It's double data rate. Okay, DDR stands for double data rate. And how is that related to your computer?
RAM.
Okay, it's a specification of a RAM. Okay, but why is DDR better than non-DDR? Okay, a long time ago, okay, your memory was not DDR. So what does DDR buy you?
So better.
Why is it better? It's faster, right? With RAM, it's always, faster is better. Okay, so double data rate means, it can transfer memory at least twice as fast compared to non-DDR type. DDR2 is slower than DDR3, and so on and so forth. Okay, so every time you upgrade to the next DDR n, whatever n is, you are increasing the transfer rate from memory to the CPU or from CPU back to memory. Okay, but it only works in one direction. Okay, it only helps when you're saying, oh, memory, I want to start with this location. Oh, by the way, I also want the next 16 items. It only goes in that direction. So if you're moving backwards, you are not going to utilize the DDR or the double data rate ability of your memory. In other words, you can buy DDR3 memory, but you'll be accessing in a pattern so that you cannot exploit the properties of DDR memory. It's the same thing with cache. Okay, what is cache in a CPU? What does it do? Why do we want to have more cache in the memory? C-A-C-H-E, cache. It helps to
Faster access.
Faster access, exactly. Cache is basically it's acting out as a buffer between the processor and memory, because talking to memory is slow. It's very, very slow. So cache is something that is sitting in between, and it keeps track of local copies or recently accessed memory items, and say, oh, since you're going to need that in 2 or 3 microseconds anyway, I'll keep it in the cache instead of going all the way to memory to write it back into memory or read it back from memory. Okay, so DDR and cache they work hand in hand. Okay, every time your program is going to execute one location that it has not accessed before, or it is not in the cache controller sometimes will say, oh, I want to put that item in the cache, but not only that item, I'll just go ahead and grab the next 16 items, because I think you might need the next 16 items as well. And that's when DDR kicks in and say, oh, I can do it very, very quickly. If you try to read memory locations one by one, it's very slow. But when you try to read memory locations sequentially, it's fast. But the sequentially only works when it's in following locations and not in previous locations. So that's why when we use a loop like this, it makes sense to go from the beginning and scan to the end, because then we'll be utilizing the full potential of the hardware. If we have DDR3 memory, we'll be using it. If we have 3 megabytes of cache, we'll be using that as well. Okay, it's not something that we really have to understand in this class. By the time we get to cisp300, even though the number is only off by 10, that's actually a fairly advanced class in programming and assembly language. So by that time, we'll look at this whole thing again. But in this case, we'll just say that start with a bracket 0 and surge to the other end. Okay. Now with this assumption, what can I do with the loop now? Well, I always focus on the exit condition first. I don't even bother to look at the body of the loop until I know what conditions I'm looking into. So in this case, how do I know there are no more items to look for? In other words, I will start from 0. If that is not what I want, I will move on to 1. I will become 1. I will become 2, 3, 4, 5, 6, and so on. So when can I get out? When I has to be greater than or equal to bar a bar. Because when I is greater than or equal to bar a bar, it is, guess what? No longer a valid index. Because the index of the last item in array A is bar a bar minus 1. So when I equals to bar a bar, we don't have any more items to look for. And there is a problem, okay? Some people look at this code and go, but isn't this bad? Because, even because we are going to attempt to compare an item in the array, even though I is greater than or equal to bar a bar. So there is a problem with that, and we'll deal with that problem. Probably not today, but later on. But today, we'll just go ahead and finish up this algorithm. So we go for revision 4. In revision 4, we finally have to figure out, okay, what do we do in the loop in order for one of these two conditions to happen to become true eventually. In other words, if I don't want this to become an infinite loop, okay, the loop has to do one of these things. It has to either change k, so that if I change the value that I'm looking for, do we want to do that? In other words, someone says, oh, here's a phone book, and my original problem is go find the phone number of Steve Peters. Okay, I look at the first item of the phone book, turns out to be John Smith. And I say, oh, I know the phone number of John Smith. Is that a proper answer?
No.
Because I'm changing the question itself, right? So we don't want to change K. Do we want to change the phone book? Okay. Are you looking for the phone number of Steve Peters? That's okay. Let me get my white out to change the first item so it becomes Steve Peters. Do we want to do that? No, we don't want to change the phone book or the item that we're looking for. Can we change I?
Yes.
Which is a bookmark to remember which part of the phone book we have already searched. So that's the only thing I can do to change, to make this condition true eventually. Because if I change I, maybe the item is in the array and eventually this condition will become true. If I change I, even if there's no item in the array matching K, guess what? I will eventually be greater than or equal to bar A bar, and I still get out of the loop. So changing I is the proper way to get out, but how should I change I? That question was answered a little bit earlier because we have already determined which direction to search in A, so that means every time I change I only have to move on to the next item. I'm adding one to I. I also want to make sure that I start with a reasonable value, like that. And we are almost done. I know we are over by 30 seconds. Revision 5 is basically just turning this loop into an actual loop, because loop and loop is just saying it is a loop, but we don't know whether it's a pre-checking or post-checking loop. So in this case, we can go for a pre-checking. If you have a choice, always go for pre-checking. That's always a better way. Okay, so in this case, I will say I is less than bar A bar, and A bracket I does not equal to K, because we have to negate the condition to turn it into this loop here. Okay. At this point, I just want to make two things. I just want to announce two things. One, the algorithm is actually done. Okay, even though it seems like attack, something is still wrong here, because if I equals to bar A bar, we'll still be evaluating both I is less than bar A bar and A bracket I does not equal to K, which means this is going to access an item out of bound compared to the bound of the array. Okay, it seems to make sense. Okay, but as it turns out, we have a method to get around that problem. So you need to read ahead of me and go to Moodle and finish up the module on searching in an array, and also what we call short-circuited evaluation. Okay, the short-circuited evaluation part is why it will explain why this code is actually going to be okay. Okay, so on Thursday, hopefully I will have all the questions graded, and then you guys will know exactly where you stand in the class. Most of you probably have an idea already.
Did you put it back up there for a second?
Sorry?
Did you put that last screen up?
I might have closed it. I can open it again. Yep.
What do we need to get a B in class?
Sorry?
A B? What's the percentage-wise for
A B? A B is from 62.5% to 87.5%.
60.2.
62.5. 5/8.
Hi, I was late and I wanted to pick up my exam.
Okay. Let me stop the recorder first. I don't think we need to record anymore. And yep, it's crashing for some reason.